Okay, putting this video together because I've had an email from someone who is using the course and they're really interested in multiplying larger numbers by 5.
Hmm.
Now, as you know, within the course, we give an example of much smaller numbers just within your times tables. And I think we give a couple of two-digit multiplications.
Hmm.
But Giovanna Ali, who says her daughter is thoroughly loving the course and it's helping with her schoolwork, she says her daughter would love to know how to do multiplications like this.
Okay.
Yeah, we got these two specific ones which they've asked for, but we're going to go into a bit more depth behind this to basically help you multiply any number by 5, no matter how many digits.
Okay.
Yeah? Let's first of all recap what we're doing when we multiply by 5 so that we can see how it relates to these larger numbers.
Hmm.
So we'll start with a basic problem like 8 times 5, well within the usual multiplication tables that you need to learn for school, just to see how the 5s work. And if you're familiar with my 3-step process, you'll know that the first step is to choose a key. We've got to choose one of these two numbers, or the x in the middle. And since in this video we're focusing on multiplying by 5, we're going to choose 5 as our key.
Okay.
Yeah? Now, with the 5, whenever we choose 5 to multiply by, the picture that we're going to link that 5 to is,
The scissors.
it is the scissors. So what do we refer to with these scissors? Do you remember what we call,
The barber.
that's it, the barber of 5s? We're going to go through the story of the barber of 5s, and when we play the thumbnail, the number 8 is going to the barber for a haircut.
Yeah.
Do you remember what the question is that the barber asks when number 8 steps through the door?
Are you odd?
Are you odd? So the number 8 is coming into question here. Is the number 8 an odd number? Now, just remind me, we've got a bunch of digits that are odd digits and a bunch of digits that are even. Which ones are the odd digits?
The ones you can't divide by 2 without making a mess.
Yes, we talk about sharing eggs, don't we?
Yep.
So if you had, for example, one egg and you tried sharing it between two people, you're going to have to crack that egg.
And
Yeah,
it's gonna make a big mess.
especially if it's not been boiled. But if we had two eggs, we could just have one each.
Yep.
We could share them evenly and there'd be no broken eggs. So 1 is an odd number, 2 becomes even. 3 is an odd number because we could have one each, but there'd be one left over that would need to be broken.
Mm-hmm.
But if we had 4, we could easily have 2 each.
Yep.
Yeah? And if we had 5, we could still have 2 each, but there'd be that one left over, making 5 an odd number because
Yep.
we'd have to break an egg there. If we had one more, we'd have 6, and we could then have 3 each with none left over. But one more gives us a problem because we could still have those 3 each, but we'd have one left over, which have to be broken if we're going to share evenly. 8, though, is a nice even number. We can easily share those 8 eggs between the two of us. But if we had one more, if we had 9 eggs, we're back into odd egg territory. And we'd have one egg that we'd have to break if we're going to share those 9 eggs between us. Yeah. So when we ask the question, are you odd? We're looking for one of these digits here. And in larger numbers, it's only the final digit that we need to look at. So the digit that's in the units column, if you like. So if you had a number like, let's say 2,460, let's go with the 3, 2,463, we can see that the 2 is even because it's not on our odd list. The 4 is even because that's not on our odd list. And the 6 is even because that's not on our odd list. All of those 3 digits can easily be shared between 2 people without breaking any eggs. But that 3 on the end, that turns the whole number into an odd number. Yeah? So when we're asking that crucial question of are you odd, we're just looking at the final digit. And in this case, the final digit is the only digit. But just planning ahead to when we're getting onto these larger problems, we just want to know, is the last digit odd? Because that's going to make the whole number odd. Yeah. So 8 isn't odd. That means the barber's quite happy to cut him. Yeah, he's going to cut his hair, and the big barber of 5s, what he does is he cuts the number in half. That's why he needs the number to be even.
Yeah.
Yeah. If he was odd, there's a little bit of extra work to do, and the barber would charge a bit of extra money for doing that. Maybe he'd pass this odd customer over to his assistant, who's going to have to trim the number down a little bit. We'll do an odd one in a second. But because the assistant is not involved in this problem, we don't need to charge for that extra work. So there's nothing going to be added onto the bill for doing a trim. Yeah. So we put a 0 down. That's going to be the final digit of our answer. Yeah. Then what we do is we look at the number here. If we cut 8 in half, what do we get?
4.
We get 4, don't we? So that 4 is what we're going to put down on the beginning of the bill. So it sits in front of the 0 that we had, and we could say that 8 times 5 is 40.
Okay.
Yep. That's what we're going to do whenever we have an even number. So when an even number multiplies by 5, the result will always end in a 0. And we put those two parts of the problem together. So there's really kind of two stages involved. There's the dealing with the odd or even numbers to decide what goes on the end of your answer. And then there's the piece where whatever's left has to be cut in half. That's the bit where we may need to develop our skill for cutting larger numbers in half.
Okay.
Yeah. So let's take 7 times 5.
Okay.
7 is from our odd number list because we can't divide 7 eggs between 2 people.
Yep.
Without having a bit of a mess on our hands. So this is where we're going to ask the assistant to step in and trim the 7 down a little bit. So the assistant's going to need to be paid for that trim. He's going to charge £5 because he's the barber of 5s. Yep. He's charging £5 to trim the 7 down by just 1 digit to make the 7 even. If you like, it's that odd egg that's left over when we try to share the 7 eggs. We're saying there's 7 eggs to share. We can have 3 each, but there's 1 left over. We're trimming that leftover egg away so that we're just left with the 6 eggs that can be cut in half, but we're charging £5 for doing that trimming. Once we've done that, we look at the 6 eggs and we say, let's divide those between the 2 of us. So we would have how many eggs each?
3.
3. So we're cutting the 6 in half to 3, and we put that 3 in front of our 5 to say that 7 times 5 is 35.
Okay.
The barber's going to charge £35 or $35 or whatever for this particular haircut. Yeah? So the 0 or 5, the bit at the end, it'll show us whether we've multiplied an odd or an even number by 5. Yeah. Multiples of 5 then are always going to end in a 0 or a 5. Yeah. And the bit that's in front of the 5 is what's coming from whatever digits we've got left to cut in half. And we're going to have a little look at what we do when we have 2, 3 or more digits to divide by 2.
Okay.
To cut in half, yeah? So what I'd like to do is take a little bit of time to focus on dividing larger numbers by 2.
Okay.
Yeah? And then we'll come back to combine these two skills together, the part where you deal with the are you odd question, and then dividing the remaining number by 2.
Okay.
Yeah? So let's take this 2-digit number. Yeah?
Okay.
You'll notice that both of those digits are even.
Yep.
Yeah, that's going to make our life very, very easy because when we divide even digits by 2, we can do them individually. So we could say if we want to cut 42 in half, we don't have to think about the whole number, 42. We can just visit each digit and cut each one in half as if it was a number on its own.
Mm-hmm.
Yeah. So we could look at the 4 in our tens column and totally ignore the 2.
Mm-hmm.
And we could just say, well, what's half of 4?
2.
It's 2. Yeah. So we'll put down 2 in our tens column for the answer.
Okay.
Yeah. And then we go along to the units column where the ones are. And we've got a 2 there, which we can cut in half. If we had 2 eggs, how many would we have each?
1.
1. So we've cut the 2 in half to a 1. And that means that half of 42, if you like, 42 divided by 2, is going to give you 21.
21.
That's what we would do with any number where all of the digits are even. We just individually divide those digits by 2.
Okay.
And it wouldn't matter how many digits there are. If they were all even, if, for example, we had, let's put a 6 on the beginning and an 8 on the end, if we were going to try and cut that in half, all of those are even digits, so we could say, well, half of 6 is how much?
3.
Good. Half of 4 was?
2.
Half of 2 was?
1.
And half of 8 is?
4.
4. So we can easily divide 6,428 in 2 and give the answer of 3,214.
Okay.
Yeah? Any questions?
If I had 42 eggs, I'd probably only eat 2 of them.
Okay. Or you could make a large omelette and share it with everyone else.
Yeah.
Let's have a look then at when we have an even number, even because the last digit is even, but one of the digits is odd. We talked in the course about how we can take a number like this and instead of calling it 76, we would call it 60 something, because 60 gives you a nice even 6.
Yeah.
Yeah. This is like when you learn to count and you're getting very proud of yourself because you can count up to 10 and you've gone beyond 10 and learned all about the teens, and then you've come across the number 20, and then you start doing 21, 22, 23, 24, and when you get to 29 you don't know what to do, so you have to learn the new name for 30, and then you're off on a roll again because you go 31, 32, 33 until you get to 39 and someone has to teach you the number 40. Yeah?
Yeah.
Every time you reach a new milestone in your counting, you have to know the names of 20, 30, 40, 50, 60. Let's just imagine what it was like when you learned to count beyond 60, but you hadn't yet learned 70.
Okay.
Yeah? And no one was around to tell you. So you might say 67, 68, 69, but you don't know what to say next. So you could say 6010, 6011, 6012. Yeah?
Yeah.
And if we were going to count as high as this number here, we would be calling that 60, 16.
Yeah.
What we've done is we've broken the 60 away from the 76 and said, well, there's 16 left over.
Yep.
What we've created now is 2 even numbers. If we added these 2 numbers together, it would give us 76. So we know that 6016 means 76, but we're just calling it by a different name. It's like a ninja number, if you like. And it's easy to divide those 2 numbers in half because just like when we dealt with even numbers a moment ago, we could easily cut 60 in half and call that 30.
Yeah.
And if we were comfortable cutting 16 in half, which I know it's a larger number, and we'll have a look at how we can help anyone who struggles with dividing those larger numbers in half. But if we knew what half of 16 was, which is how much?
8.
8. we could combine that with our 30, and we'd have 38. Yeah, 38. So 76 cuts in half to 38. Let's just take a little moment to consider strategies for dividing 16 by 2 for anyone who would struggle with that. Yeah?
Okay.
You may remember when we were doing the multiplication by 2. Do you remember what picture we used for multiplying by 2?
The ladybug.
The ladybug, yes. So let's just take a quick look at what we did with that ladybug when we multiplied small digits by 2. We chose 2 as the key. The picture for the 2's was
The ladybug.
the ladybug. We imagined a ladybug like this. Yeah? I know it's a bit of a rough drawing there, but there's my ladybug. And when we press the thumbnail to play the story for the ladybug. So the ladybug is what's representing the number 2, and it's the number 3 here that's going to be ladybugged, if you like. And the way this worked is we'd say there are 3 dots on one of the ladybug's wings. And if you remember, we could never have more than 5 dots on a ladybug's wings. But we've got 3 dots all on one wing here. And with our ladybug, you'd always have the same number of dots on the other wing. So we would basically be adding 3 plus 3, because we've got 3 on the left there and 3 on the right. And then when we look at this ladybug, we can see that we have 6 dots in total. So to multiply by 2 simply means, can we take 3 and add another 3? It's 2 lots of 3. 2 3's added together. When we add 2 3's, we get 6. So when we multiply 3 by 2, we're doing the same thing. We still have 6. That's the number of dots on the ladybug's wing.
Yep.
Yeah, that was what we did with any digits that didn't complete a full ladybug. So small digits like 1, 2, 3, and 4.
Yep.
Yeah. When we got to 5 dots, however, if we were going to choose 2 as the key, which we can do, although we could have chosen the barber. Yeah, you've got a choice on this one. They both give you the same answer, as you know. But if we choose 2 as the key, we'll have the ladybug. And we've now got 5 dots to put on this wing. We can fit 5. But we're going to need to put 5 dots on the other wing. That's what we refer to as a full ladybug. And it looks like an awful lot of dots to count, but if you think of the fact that most people have 5 fingers on each hand, when you say to most very young children even, what's 5 plus 5, they can very quickly tell you the answer.
10.
10. So 5 plus 5 gives us 10. And we talked in terms of this being a full ladybug, or what I like to call a handful. Those full ladybugs, they fly away. The answer is like 1 handful, and when that ladybug's flown away, there's nothing left.
Yep.
Yeah? So the answer to 5 times 2 is 10, just like 5 plus 5 would give you 10, because that's what we're doing when we multiply by 2. Yeah? And then we looked at slightly larger digits, like let's take our number 8. If we're going to multiply that by 2, let's say again we choose 2 as our key, so we're going to use the ladybug. And this digit is too many dots for one ladybug's wings. So do you remember what we did? We said we'd think of the number 8 as being a handful and a bit. We would split that number 8 into a handful, which is the 5 dots, plus a little bit more. And we learned how to look at the larger digits, 6, 7, 8 and 9, as being a handful and a bit. So the 8 is a handful of 5 plus an extra 3. Yeah. Now the 5 is our full ladybug. That's the one that flies away. So we've got one flown away ladybug. That one has flown away to sit in the tens column. So our answer is going to have tens and units in it. Yeah?
Yeah.
Essentially, that 5 has become, just like in the last problem, 5 plus 5 is 10.
Yeah.
So we've taken the 5, we've let it become a 10 by putting a 1 flown away ladybug into the tens column. What's left over is the 3, the handful and a bit. The bit is left over. That's the only bit we need to really think about. We'd put 3 dots on our ladybug here, and we'd think of what is 3 plus another 3. What's 3 plus 3?
6.
6. That's what's going to sit in our units column. So 8 times 2 gives you 16.
Okay.
That's not the answer to 5 plus 3. The 5 plus 3 was the 8. So 8 times 2 is 16. So any of these teen numbers that are even, well, we've got numbers like 12, 14, 16, and 18. They're even numbers that sometimes people would have difficulty dividing by 2 because they just seem too big to handle in one go. But if you notice, with each of these, we've just got a handful from the 1.
Yeah.
And a bit that has been multiplied by 2. So if we just focus on dividing the units number, the one in the ones column, by 2, we cut the 2 in half, that gives us 1. But we've got this handful that we need to combine with the 1. Yeah. So our handful represented a full ladybug with 5 dots on each wing. So we think of 1 as being a handful plus the 1.
Okay.
Yeah. 5 plus 1 gives us 6. So 12 cut in half becomes 6. The 10 cut in half to the 5. The 2 cut in half to the 1. Yeah. We can use that exact same strategy with any of these teen even numbers. We look at 14, we can cut the 4 in half to a 2, but we're going to call that the bit that we add to the handful. So we've got 5 and a 2. What does 5 plus 2 give us?
7.
That gives us 7. So 14 divided by 2 gives us 7.
So does that mean 7 times 2 is 14?
It does indeed. 7 times 2 we would break into a handful and a bit. 5 and 2. The 5 becomes our full ladybug that flew away.
Yep.
The 2 we double up. 2 plus 2 gives us the 4.
Okay.
Yeah. So 14 and 7. 14 is twice 7, or 2 times 7. 7 is half of 14. Or 14 divided by 2 is 7.
Okay.
And if we look at the 16, let's see if you can do that one.
So I would cut the 10 in half. I get 5, which is the full ladybug.
That's it, that's your handful. We got 5, yeah.
Then I'd cut the 6 in half to 3.
Yep.
And then I would do 5 plus 3, which is 8.
So you get 5 plus 3, which is 8. So when you start to think about these speedily, you look at 16 divided by 2 and you'd say, well, that's going to be the same as 5 plus 3. Because what you're doing there is you're taking what looks like a hard problem and swapping it over for an easier problem that has the same answer. I'll clear the sheet and we'll look at doing 18. Clear that off. We're trying to do 18 divided by 2, and we're facing a test. We're trying to put the answer to that in, and we're thinking, if only I had a different problem that gave me the same answer. Yeah. Instead, we're going to swap this problem out for, I'm going to turn that 1 into my full ladybug, handful, and I'm going to add to that whatever half of 8 is.
Is half of 8 4?
Half of 8 is 4. So we've created a replacement problem that's going to have the same answer. Now, would you agree that 5 plus 4 is a nice easy problem to solve?
Yep.
Yeah. What's the answer?
9.
9. So we would think of the problem as 5 plus 4 instead of 18 divided by 2, but we can put the same answer in the box there because this is going to be correct.
Okay.
Yeah. So we're going to use this strategy when it comes to dividing these large numbers by 2. But it was really important you get the hang of dividing these teen numbers because that part can be a stumbling block for some people. Yeah. So let's have a look at how we would apply that to this problem here where we're trying to divide 76 by 2.
Okay.
Yeah. We would look at this 7. Earlier on we said we could turn this into 60 16.
Yeah.
The way that we're going to process this with long numbers is we're going to say, well, look, 7 is an odd number. We're going to look at the 7. We're going to say, we have 7 eggs to divide between the two of us, but we know that that's going to get messy. But if we put the odd egg to one side, we could divide the other eggs by 2, couldn't we? So we're going to park the odd egg over here. What we're really doing at that point is we're creating that number 16. Yeah. Once we've parked the odd egg, we've only got 6 left here because we removed the odd one. That 6 sitting in our tens column is our 60. This is where 60, 16 comes from.
Okay.
Yeah. So whenever we see an odd digit, we just put a little parked odd one over here. It's never going to be more than 1, which is why we only need to cut down teen numbers in half, nothing bigger than teens. Now, this 6, we don't need to think of it as 60. We can just treat it like a 6 in the tens column. So when we cut 6 in half, we get how much?
3.
3. And then we come to do this one here where we want to divide 16 by 2. And we're going to do our little trick where we say, well, the 10 is our handful. That's giving us a 5. And when we cut 6 in half, just like we did over here, we get how much?
3.
3. But this is going to be where we find a substitute problem. Instead of doing 16 divided by 2, we think of it as 5 plus 3, which is how much?
8.
8. That's our little hack for finding half of 16. So we end up with the answer 38.
Okay.
Yeah, we've divided 76 by 2 and our answer was 38. Yep, that's what we'll do. Okay, do you have any questions?
I don't have a question, but I like the way you can turn dividing big numbers into a simple addition problem.
You do? I like that too, because I prefer easier problems to deal with.
Yeah, you can just change it into a simple problem.
If you can learn to do that with everything in math, whenever you have a difficult problem to deal with, by breaking things down into easy things to do, everything becomes easier. There's a life lesson there. Okay, so let's step it up a bit and look at some 3-digit numbers.
Ooh.
Yeah, 846. What do you notice about those 3 digits?
They're all even.
They're all even. That's going to make our life very, very easy for this, isn't it?
Yeah.
Because we're just going to deal with each digit individually. If we're going to divide 846 by 2, we just pick them off one at a time. So, what's half of 8?
4.
4. What's half of 4?
2.
And what's half of 6?
3.
3. So half of 846 is going to be 423.
Okay.
Straightforward?
Yep.
Good. Any questions?
No.
Lovely. Then let's look at what happens when we throw an odd digit in. Can you spot the odd digit?
The 3.
The 3. So let's not worry about the 3 at all. We know that we've got a strategy to deal with it, but let's just start off on the left-hand side here with this nice even 6. What's half of 6?
3.
3. And then when we come to our 3 here, what do? We're trying to share 3 eggs between the 2 of us. We don't want to get in a mess. What are we going to do with the odd one?
Are we going to move it over to the 2?
Yeah, we'll park the odd one up there. So that essentially becomes a 12. Yeah. Now that we've removed the odd one from the 3, what's left?
2.
2. That's a bit like when the barber's assistant takes an odd number and trims it down.
Yeah.
He's removed the odd part. So 3 becomes a 2. How can I do that? Let's just put a 2 up here. Cancel our 3 out there. So we now have an even number which we can cut in half.
Okay.
What's half of 2?
1.
1. Excellent. And then we're going to move on to the 12. We now need to use that strategy where we think, I don't want to cut 12 in half. I'd rather add 2 simple numbers together. One of those numbers is going to be related to this handful, this odd egg that's come across from the tens. What does that handful represent when we add 2 numbers?
5.
5. So this is 5 plus the bit. We're going to cut 2 in half again.
1.
1. So we think of 5 plus 1 instead of 12 divided by 2. Because 5 plus 1 is nice and easy. What's 5 plus 1?
6.
6. So we have 6. There we go. We took 632. We've cut it in half. And we've got the answer 316.
Okay.
Yeah? Any questions?
How do you make it so simple?
The fact is, it is simple if you know how to look at it.
Oh.
Yeah. Okay, so let's have a look at what happens if our odd digit isn't in the middle. What if the odd digit's right at the beginning there? Is that really going to be any more of a problem?
No.
What should we do when we start off dealing with this number?
So we take one from the 7 and park it next to the 2.
That's it. We'll put the odd one over here so that we can treat this as if it was a number 12. What's left in place of that 7?
6.
6. So we just have to think of cutting 6 in half.
3.
3. Excellent. And then we're going to try and cut 12 in half. Talk me through what we do there, because we don't want to do 12 divided by 2 until we become comfortable with it.
We change the 10 to a handful.
A handful.
5.
5.
And then we cut the 2 in half. Which is 1.
We got 5 plus 1, which is
6.
6. Excellent. And then we can move on to the 8, which is even, meaning we can just cut that in half to
4.
4. So we have divided 728 by 2. We've cut it in half and reached 364.
Okay.
Yeah. Now, this idea of turning 12 divided by 2 into a different problem, 5 plus 1, you'll find after a little while that your brain will wire things together so that you don't need to even swap it out anymore. You'll come at some point to just recognise that when you divide 12 by 2, it's a 6.
Yep.
Yeah, but this is like a stepping stone to help your brain wire that together.
Okay.
So over time, you'll get faster and faster at doing these things.
Yep.
Yeah? Okay, so let's step it up again and look at what happens when we have 2 odd digits right next to each other. We'll just pick them off one at a time, because 574 looks like a massive problem to deal with, but if we just treat each digit individually, we make the problem easier. If we had 5 eggs and we needed to share them between us, what's the first thing we would do?
We'd park one next to the 7.
We'll park the odd one over here, shall we? Yeah.
Yeah.
And what are we left with instead of a 5 there?
4.
We've got a 4, haven't we? Let's get rid of that. Call him 4. What's half of 4?
2.
2. There we go. Then we come along to this 17. What do you notice about 17?
It's an odd number.
It's an odd number. So what are we going to do?
We're going to park one next to the 4.
Park one next to the 4. And instead of 17, we'll call it
16.
16. So we're trying to now divide 16 by 2. That looks terrible. So we're going to swap that for a simple addition problem. What 2 numbers do we need to add together when we're trying to cut 16 in half?
We change the 10 to a full handful,
Mm-hmm.
which gets 5.
5, yep.
And then we cut 6 in half,
Yep.
and we get 3. So 5 plus 3.
5 plus 3, which is how much?
8.
8. So half of 16 is 8. Yep. And then we move on to the final number, which is 14 here. Is that even?
Yes.
It is even. So we could say, can I divide 14 by 2, or is that too hard? If it's too hard, we can use our simple little trick here. Swap it out for a simple addition problem. It's always going to be 5 plus something. We've just got to cut the 4 in half,
Which gets 2.
which gives us 2. So the question is, what is 5 plus 2?
7.
7. So half of 14 is 7. We've divided here 574 by 2, and we've got 287. Do you want to check that on your calculator?
Yep.
574
574 divided by 2 equals 287.
Excellent. So we know it's working for certain.
Yep.
Yeah. So I think we're ready to put this all together and go back to multiplying by 5. If you remember, dividing a number by 2 is just part of how we deal with this, because we first had to deal with that question the barber asks when, in this case, 9,516 steps into the barber shop. What's that question?
He asks, are you odds?
Are you odd? Now we've got an odd 9, we've got an odd 5, we've got an odd 1,
But an even 6.
but an even 6. And that even 6 is the only one we need to focus on because it's the final digit.
Yeah.
So that makes 9,516 an even number.
Okay.
Yeah. That means we're not going to have to charge for trimming this down to make an even number. So we'll put nothing on the bill for a trim. The assistant isn't getting paid today for trimming this number down.
Okay.
Now the barber says to the 9,516, sit down in my chair. He gets his big scissors out, make sure they're very sharp, because this is a huge number to cut in half, isn't it? It might seem like it, but it's really just 4 individual digits that we're going to deal with separately.
Okay.
Yeah? So let's first focus on this 9. He's odd. So what do we have to do?
Park one next to the 5.
We'll park the odd one here. And we'll turn that 9, we'll trim it down, trim this down into an 8. Good. Now that he's even, what can we do?
Cut him in half.
What's half of 8?
4.
4. Excellent. Well, that's part of the haircut dealt with.
Yep.
We're ready to move to the next digit. Yeah? We've got 15. What do you notice about that?
It's odd.
It's odd, so what do we need to do?
Park one next to the 1.
We'll park the odd one over here. And 15 becomes
14.
14. Now, we might be comfortable simply dividing 14 by 2, but if we're not, we're going to use that little trick.
We're going to change the 1 into a handful, which is 5.
So it's always going to be 5 plus something, yes?
And then we're going to add half of 4, which
Good.
is 2.
Which is 2. And the answer to 5 plus 2 will be the same as the answer to half of 14. What is 5 plus 2?
7.
7. So half of 14 is 7. Yeah? So we're halfway through the haircut now. Good. And we're moving on to the 11. What do we notice about that?
It's odd.
It's odd. So what are we going to do with the odd bit?
We're going to park one next to the 6.
Good. And 11 becomes
10.
10. And we've got to do half of 10. That might seem hard.
Yeah.
What's half of 10?
5.
It is 5. You probably know that because you've got 10 fingers and one hand has 5 fingers. Or you could still do this little trick up here. You could say, well, the 1 is like a full ladybug. So there's my 5 from the full ladybug. And I'm going to add to it half of nothing.
Which is 0.
Which is 0. And 5 plus 0 is?
5.
Simply 5. So we've got a 5 there. And then finally, get rid of that. Finally, we're going to move on to the 16. This last number that we cut in half in the barber story, this last one will always be even. Because if the 6 were odd, the assistant would have already dealt with it. Yeah? So we're always going to have an even number in this position. We might know what half of 16 is, but if we didn't, let's use our 5 plus trick. It's going to be 5 plus half of 6, which is
3.
3, good. And what's 5 plus 3? 8. So we pop an 8 down there, and we've got our answer. So 9,516 times 5 should give us, gosh, that's a big number. Let's just check how many digits do we have. From the end, we'll count back 3 places. I'm going to put a comma in there to separate this part of the number from this part.
So that will be 47,580.
47,580. Now, I'm not too sure that's right.
I'll just check it.
That's a good idea. Type it in.
9,516 times 5 equals 47,580.
47,580. So you got it right first time.
Yay.
Was there anything hard in there?
Not really.
So it looked like a very challenging problem, certainly. This is all about getting comfortable with mental arithmetic. Most people, when they see 9,516 times 5, you think about what they would do. You do this thing where you do times 5 and you put a line under here and you say 6 times 5, and you have to either remember your 6 times table or your 5 times table, and you say, oh, 6 times 5 is how much?
30.
Oh, 30, is it? Right, okay, so we put a 0 here, and then we have to, I think some people like to write the 3 down here or somewhere else.
There.
Oh, do you put your 3 up there?
Yeah, you put
some people put it up there and some people put it over there. I'm going to put it, I don't know. And then they say 5 times 1, which is
5.
5, and then they add this 3 to it to get an 8. And there's nothing to write down there this time. And then 5 times 5, which is
25.
25. So we'll put the 5 there, and we have to put a little 2 down here. And then we're doing 5 times 9, which is
45.
45. But we've got to add this 2 to it, giving us
47.
47. And it's not until we get to the very end of that problem that we know what the kind of size of the answer is. Because we were dealing with the details first, the little details, and then building up towards the main part of the solution.
Okay.
And there was actually a lot more mechanical difficulty doing that than there was with what we had done earlier.
Yep.
With the mental arithmetic. And if you were building the number up in your head backwards, if you weren't actually writing those numbers down, by the time you get over to the 47, you might well have forgotten what the 580 was. You just forget those digits.
Because you're doing it in your head, you might trip up a bit and forget what numbers were written at the bottom that you had on.
I do see that happen quite a bit, yeah. If you put the number down in the wrong place or forget to add it on, or if you mess up one of those multiplications by 5, that does happen. When we're doing the barber story, we look at this and we say, well, I know there's going to be an extra digit in the answer. Let's put our answer up here with the barber story. I know there's going to be an extra digit, a 5 or a 0. And I know I'm going to have to cut all of this in half. So I know I'm going to have 5 digits in my answer. So I could think ahead and know that we're going to have to break there to have our hundreds, tens and units. And this will be our thousands. Yeah. And the way I would look at this, if I was in a situation where I don't have any paper and someone says, what's 9,516 times 5? I'd quickly visualize that in my head to know that I've got tens of thousands. Then I'd start at this end. I'd even think about the are you odd question right at the very end. Let me show you how it works. I'd be looking at this and say, well, I know that I just want to cut that 9 down to an 8 and carry over an odd one, but I haven't got a bit of paper to park the odd one. So what I'd do is I'd say, well, let me just deal with the cutting the 8 in half. And I'd immediately call that 40, and I'm thinking 40 something thousand. I'd say 40, and as I look to this digit, the 5, I would just glance back and see, that was an odd one. So this isn't a 5, but a 15. Yeah? And then I'd say to myself, well, 15's odd, so I'm just going to forget about the odd bit. I'll cut 14 in half. So all I've spoken out so far is 40. The next thing that comes out of my mouth is the half of the 14 here, which is 7. So it comes out 47,000. So someone who's listening, they're just going to hear 47,000 so far. Yeah. In my mind, I'm looking ahead now to the 1. But I glance back and I see that the 5 was odd. I don't even have to remember that it was a 15. It's just the fact that the 5 was odd because it's the last digit that makes the number odd. So I know there was 1 carried across here. So it's not 1 I'm dealing with, but 10. Yeah? So I'm just going to think about cutting 10 in half, and that's going to give me a 5.
Yeah.
So the next thing that comes out of my mouth is 500. Yeah. So I'm processing it in my head, making the answer up as I go along. I'm not having to remember the 47,000 because I've already spoken that answer out.
Yeah.
I've already said 47,500. Yeah. And as I come to the 6, I take a little glance back and I see there's a 1 there, so it was odd. So I know I'm dealing with 16.
Yep.
Yeah. And I know that 16 is even. So I can cut it in half and I get 8.
Yep.
So I've said 580.
Yeah.
It's the last digit now. This is where I simply look at this digit here and say, was that an odd one? Because as it wasn't, the assistant wouldn't have got paid. So 580, and there we are, 47,580. Was that the same answer we had earlier on?
Yes, it's
There it is, right down the bottom, 47,580. And to me, not only does it help you get a general size of the answer right up front and deal with the big picture and then fill in the details, but it helps you in situations where you need to speak the answer out to someone but you don't have a piece of paper to do the whole thing backwards and do this multiplication here. So let's have a look at this other problem that Giovanna put to us. Giovanna, if you're watching, see if you can have a go at this for yourself. And anyone else watching?
Yeah.
See if you can do it. We'll take it slowly. We're going to try and do this the way where you're just speaking out the answer. So we can see we have 4 digits here. We know we're going to have a 5-digit answer. Let's not even do the are you odd question at the beginning. Let's just see how this goes. Yeah. So we're going to look at the 9. We're not going to worry about the fact that it's odd. We're just going to forget about the odd one and cut in half the bit that's left over. So what's half of 8?
4.
So we're going to call
40.
So we're going to say 40.
Yeah.
We don't know what's happening here yet, but 40. Then when we come across to the 7, we're taking a glance back here to see that that was odd. This 7 becomes a 17. But we'll forget about the odd bit and call it 16. Half of 16 is
8.
It's 8. Doesn't matter whether you did that by knowing half of 16 is 8 or whether you did the little 5 plus 3 trick in your head. Yep. But what we're speaking out is 48,000. We're moving on now to the 2. And take a quick glance back. We can see the 7 was odd. So 2 is actually...
The 2, 12.
It's the 2, 12, which is even. So we'll cut 12 in half. We get
5 plus 1, which is 6.
So 6. But all we're speaking out is 48,600. And we're ready to now do the 3. A quick glance back here tells us that it's not 13. It's just a 3. But 3's odd. Forget about the odd one. We'll cut the 2 in half.
Which is 1.
So we've got a 1 there. Yeah. So 48,600 and it looks like it could be a strange number to say because we don't know whether that one's going to be a 10 or an 11 or a 12 or anything like that. So we won't speak it out yet. We'll just hold that one in our head. There's only a 1. And we've just got to glance down here to see that that 3 was odd and know that the assistant would have been paid £5. So this 1 becomes a 15. So we would have said 48,600 and pause 15. Yeah? And that was the quick way doing it. Let's just see if that answer's right for a start.
Let me double check the calculator. 9,723 times 5 equals 48,615.
Brilliant. And if you get fast at doing this, you'll find that it's quicker to just speak that answer out than to go and find your calculator, type it in, check that you've typed it properly, and then read the answer out. You can get really quick at doing this with a little bit of practice. Now that one we did without following the written process, but let's go back and just do it the full way as well. So if we had 9,723 times 5, the barber could ask,
Are you odd?
Are you odd? And we're looking just at the 3 there. Is 3 odd?
Yes.
Yes, so we're going to put a 5 on the end. So this is the sort of thing you would do in a school test where you've got a bit of paper to write the answers down on. you've got the luxury of being able to write that 5 down now. Yeah, and we can forget about that 3 and call it a 2.
Yep.
Because we've trimmed him down. Yep. Then we're going to move right to the other end of the problem. We're looking at this 9. What do we do with the 9?
We park 1 next to the 7 because
Good.
9 is odd.
We'll treat that 9 as if it's an 8.
Then we cut the 8 in half.
Mm-hmm.
We end up with 4.
4. Good.
Then we look at the next number, which is 17.
Mm-hmm.
17 is odd, so we park 1 next to the 2. Turn the 17 into 16.
Mm-hmm.
Then we cut the 16 in half, which is 8.
Mm-hmm.
It's also 5 plus 3, which is also 8.
Yes.
And we take the 12, and it's not odd this time, so we can cut that in half. 12 cut in half is 6, which is also 5 plus 1.
Good, yes.
And the 2 isn't a 12, so 2 is even, and we can cut that in half, and we end up with 1.
That's the end of our even number being cut in half. The 5 that the assistant was paid is on the end, so we could look along here, count 3 spaces from the end to put our comma, and we'd have 48,615. Is that the number that you had?
9,793 times 5 is 48,650.
Excellent. So, was that hard?
No, not at all.
Not at all. Let's go crazy now, shall we? Let's go for a nice big number. Let's say we're going to try and multiply 3, 2, 4, 7, 6, 1 by 5. And we're going to do it the speaking out way.
Okay.
Yep. So we do 5 times 324,761.
Okay.
We're going to start with this verbal method. We're going to hit the 5 times 3. Well, we're not doing 5 times 3. We're just cutting 3 in half. But 3's odd.
So we park 1 next to the 2.
But we're not even thinking like that. We're just doing this speaking out thing. Where we're going to look backwards as we go. We just look at the 3, but we see 2.
Yep.
And we cut 2 in half. Becomes
A 1.
a 1. Now, as you look at that 1, there's no way that that 1 can be 100,000. So that 1 has to be bumping over into another extra column. So that 1 has to be a 1 million. So we know what we're dealing with is 1 million and something. Yeah? So we've dealt with the 3, we're going to bump along to the 2, and we just look back and see that the 3 was odd. So we're not dealing with 2, but 12. What's half of 12?
6.
6. So it's
Which is also 5 plus 1.
5 plus 1, which is 6. So we've got 1,600,000. We're ready to deal with the 4. We'll cut that in half to
2.
So we'll say and 20. And then we're going to look at the 7. As we look back at the 4 and see that was even, we're actually dealing with the 7. But we're going to forget the odd one.
Think of it as 6.
Think of it as a 6. We'll cut 6 in half.
6 in half, we get 3.
We say 3, and we say 1,000. We're ready to move over to the 6, but we look back and see that 7 was odd. So the 6 is actually a
16.
16.
So we can think of that as 5 plus 3, which is half of 6.
Which is half of 6. So that's
5 plus 3 is
8. So we say 800.
800.
And we'll go across to the 1. And we'll say, is that actually a 1 or an 11? We look at the 6, see that was even.
So that is just a 1.
So it is a 1, but it's an odd one. So we'll trim that down. What do we have?
0.
0. What's
And
half of 0?
0.
It is, because if we had no eggs, we could share those equally between us, couldn't we?
Yeah.
And have no eggs each. So it's 800. And to fill in that last bit, we just ask, was the assistant paid?
Yes.
And he was, because of that last digit there. Yeah? So we put a 5 on the end. Now I'm a bit nervous about this. Grab the calculator. 5 times
5 times
324,761. What do you have?
1,623,000
Mm-hmm.
805.
805, and that's exactly the same as what we got.
Okay.
Yeah. Well, that's it, Giovanna. I hope that was detailed enough to help you through those problems and more besides. And that's how we're going to multiply any numbers as large as you like by 5. Have fun with that, and feel free to keep posting any questions. If you've watched this and you're wondering what on earth these 3 steps are all about, when we were doing these picking a key and choosing what picture goes with the key, which was for most of this video was either the scissors for 5 or the ladybug for 2. We always choose the same picture with each key, and once we've chosen the picture, we turn that into like a thumbnail to play the story. And what you've been watching today is playing the story of Ladybug Stories and Barber of Fives. There's a whole range of picture stories that we've put together in the Numba Ninja course, which will help you multiply up to 12 times 12 and well beyond, as you've just witnessed here, just by learning a series of picture stories. If you're interested in checking out the course for yourself, you can go and take a completely free trial over at Numba.Ninja. And let me know what you think. Thanks, guys, and see you next time.
Bye.
Bye.